Hello Internet and welcome to this quick video on elastic potential energy, perfect for GCSE Science. Now, we can start by saying that stretching or squashing an object can transfer energy into its elastic potential energy store, and we have an equation to work out the elastic potential energy. And this is our elastic potential energy, which is measured in joules, as all energy is, equals 1/2 times our spring constant, which is measured in newtons per meter, times extension squared. And obviously extension is measured here in meters. And this would generally be simplified down to EE, which is just elastic potential energy, equals 1/2 KE squared. You will need to remember this. Now we can take a look at a couple of examples of questions. If you'd like to pause the video once the questions are on screen and give them a go for yourself, please do feel free, otherwise just follow along with me. So the first question here tells us that we have a spring, and this spring has a spring constant of 22 newtons per meter, and is stretched out 14 meters. We are then asked to calculate the energy in its elastic potential store. So all we're going to do here is plug our values into the equation EE equals 1/2 KE squared, and putting that in a calculator, we get an answer of 2,156 joules. This next question's a little harder as it requires a bit of rearranging. So again, if you'd like to pause this and give it a go for yourself, please feel free, otherwise just keep following along. So this time an object has 12,000 joules of energy in its elastic potential energy store, and a spring constant of 18 newtons per meter. Calculate the extension of the object. So here, obviously, we're not finding the elastic potential energy, so we are going to have to rearrange quite a bit. So plugging our values in, we get 12,000 equals 1/2 times 18 times E squared. I've just left E squared there, and we're going to solve this algebraically. So whichever we do to one side, we must do to the other. Therefore, let's start by getting rid of a half. We are currently timesing by a half on the right-hand side, so we're going to divide both sides by a half, which is effectively timesing by 2. Therefore, getting an answer of 24,000 equals 18 times E squared. The next thing we're going to do is divide both sides by 18, which will give us 24,000 over 18 equals E squared. And then finally, we're going to square root both sides. And this will give us an answer of root 24,000 over 18 equals E. This is what we want. So putting this in a calculator, we get an answer of 36.51 meters.